This lesson is on Learning Target 3, Models and Probability. And this is for our unit on statistics. Today's target is I can model and find simple probability. So what is probability? Probability is the chance or likelihood that an event will happen, the ratio of the number of ways an event can occur to the number of possible outcomes. We call this way of writing probability notation. And we always put the number of the events that we are measuring over the total number of outcomes that could happen, such as the number of times that I get heads out of the number of times that I would flip a coin. The event would be get heads, but flipping is the total number of things. There's two types of probabilities we'll work on. The first kind of probability, it is the chance that something will happen or how likely it is that some event will happen. Theoretical probability is the ratio of the number of favorable outcomes to the total number of possible outcomes. In general, probability is what you get from actually trying to do it. Theoretical probability is kind of the probability of the thing without actually doing the thing. So I could make a probability of flipping a coin and seeing how many times I get heads, but the theoretical probability of getting heads is still only 1 out of 2. So let's do a little bit of comparison of probability and theoretical probability by rolling a dice. So I'm going to roll this dice and log what I get. I get a 3, so I put a tally mark here. I'm going to roll the dice again, and I get a 2. I'm going to continue rolling this dice and logging in all those tally marks until I've rolled it a total of 20 times. Okay, so let's total up how many times I got those sides of the dice. I got a 1 rolling it 3 times. I only rolled a 2 1 time. I rolled a 3 twice. I rolled a 4 5 times. I rolled a 5 only 3 times, and I rolled a 6 5 times. So the probability of me rolling a 4 would be 5 times out of 20. So 5 divided by 20 is equal to 1 out of 4, or 0.25. So I have a 0.25 chance of rolling a 4 according to the probability of my little experiment. But the theoretical probability is still the number of sides of the dice that actually have a 4 on it. And there is only one side of the dice that has a 4 on it. So I would only have a theoretical probability of 1 out of 6 sides of the dice. Which is equal to 0.17 rounded. So sometimes it's the case through doing an experiment that the probability you get from actually doing the event does not actually match the probability of the object or the event itself. There's 2 ways to do probabilities of things happening simultaneously. Compound probability is another way of saying multiple events. There's 2 keywords to look for within the problem, within the text of the problem, that are clues to the way that you should actually do the probabilities and come up with a final answer. If you see the keyword of or, then you should be adding the probability of the two things that the problem asks. If you see a keyword of and, you should be multiplying the probability of the events in the problem. Let's try each of these two different setups of keywords or and keywords and. So I got this bag. This bag contains a whole bunch of marbles. There's 5 red marbles, 6 blue marbles, and 4 green marbles. I'm going to conduct a little experiment. And every time I do my experiment, I'm not going to replace the marbles that I take out. So what is the probability? What is the probability of getting blue or getting red? Well, the probability of pulling out a blue would be 6 out of the total marbles. 5 plus 6 plus 4 is a total of 15 marbles. So I have 6 out of 15 marbles. Since this says or, I am going to add. Or the probability of getting a red. Now, since I'm saying the word or, I'm only taking out one marble, a blue one or a red one. I'm not taking out 2 marbles. So my next probability would still be 5 red marbles out of a total of 15 marbles. I add these together and I have a 11 out of 15 chance of pulling a blue or a red marble. 11 divided by 15 is 0.73, or a 73% chance of getting a blue or a red marble. Our second probability says, what is the probability of getting a blue marble and then a red marble and then a green marble? So in this scenario, I am taking out 3 different marbles. And remember, our experiment says without replacement. So what's the probability of first pulling out that blue marble? Well, that first blue marble is 6 out of 15 marbles. Our red marble, once I've taken 1 blue marble out of the bag and I have not replaced it, there are 5 remaining red marbles that are a possibility, but they're no longer out of 15 in the bag because I didn't put that first marble back in. That would be out of 14. And the green marbles are still out of 4, but I have now taken 2 marbles out, so it's out of 13 marbles. Key word here is and, so I am multiplying each of these probabilities to come up with my answer. So 6 over 15 times 5 divided by 14 times 4 divided by 13 gives me a fraction of 4 out of 91. Or in other words, 0.04 chance, or only 4% chance of these 3 events happening together. So that covers probability in a few different ways. Doing experiments, our experimental probability, or our theoretical probability. Thinking about the words or and also getting used to probability notation, the P with parenthesis and the events inside the parenthesis. Don't forget to answer the questions. Send me any questions that you have about the notes, and don't forget to hit that submit button.